Central to the framework of hypothesis testing is the idea of a statistical hypothesis. A statistical hypothesis is some statement about the value of an unknown parameter from a population. But when we're thinking about hypothesis testing broadly, we're typically focused on two specific types of hypotheses, namely the null hypothesis and the alternative hypothesis. So, in order to actually conduct hypothesis testing, then we're going to rely on the specification of these statistical hypotheses, and again, the null hypothesis and the alternative hypothesis. And these are going to be statements regarding the values of population parameters. By specifying hypotheses that are valid for the questions we're interested in, when we draw conclusions from hypothesis tests, then we're going to be able to actually make use of those conclusions in the way that we would like to. So, what is a statistical hypothesis? A statistical hypothesis is any statement about the value of a parameter, of an unknown parameter. So, what we're really thinking about there is that we're hypothesizing about the underlying truth. When we say this parameter has this value, what we're really saying is, in the world, this is our hypothesis about how things work. Right? And so it's a guess as to the way that things work, and it's probably going to be informed by experience that we already have. Okay? Importantly, this has to be a statement about a parameter, not about a statistic. There's nothing random in a hypothesis, right? We're making a statement about the way that the world actually is, and the way that the world actually is governed by the values of parameters, not by the values of statistics, right? So we're not thinking about this as a random statement. We can either specify equality-based hypotheses or inequality-based hypotheses, right? So we can either say the value is going to be equal to something, or maybe we'll say it's greater than or equal to something, right? So we can sort of make the statement in any way, but what we really need to be doing is comparing a parameter to some value. Okay? So, for instance, we might say the population mean is equal to 15. This is a hypothesis because it deals with a population parameter, in this case the mean, and we're saying it's equal to some specific value, in this case 15. The population proportion is less than 0.4. Again, this is a hypothesis. It deals with an inequality here, right? The proportion is the parameter that we're interested in, and we're comparing this through the less than operator to the value of 0.4. Now, it's going to be possible to have hypotheses that have more than one parameter in them. So you could think about, the mean of one population is greater than the mean of another population, for instance. So we're going to be able to make statements that involve more than a single parameter. But again, they have to be about parameters, right? So the mean of group A larger than the mean of group B. The proportions in populations 1 and 2 are not equal, right? All of these are still statements about parameters, but here now we have statements about two parameters at any given point, right? So as long as it's a statement about the value of one or more parameters, then we're thinking about that as a statistical hypothesis. Okay? Now, when we want to do hypothesis testing, we are going to require the specification of two very specific hypotheses. We need a null hypothesis and we need an alternative hypothesis. And these are going to be sort of sitting at the core of the hypothesis test that we're going to run. So what is the null hypothesis then? Well, the null hypothesis captures our default belief about the world. It's supposed to represent what we think is actually going on. The idea is that somehow we're capturing the underlying truth with the null hypothesis. It's kind of a boring hypothesis in some sense, right? So we're trying to codify what we believe to be true, and specifically what we would believe to be true if we didn't have any additional evidence, right? So if you're not going to do the hypothesis test, what do you think is actually true about the world, and what are you going to go on believing is true about the world, right? If you did not know how to do any of this process, what are you going to take to be true? How are you acting right now? So another way of thinking about the null hypothesis is that it's in some sense the most conservative way of acting, right? So the idea is that we don't need any evidence for the null hypothesis. It's what we're sort of just taking to be true. And so we typically want this to be a safe place to be, right? So we want this to be a safe hypothesis to follow. Okay. When we think about specifying the null hypothesis, we can either specify it as being equal to, greater than or equal to, or less than or equal to the value that we're clarifying, okay? But notice that in each one of these cases, we actually have an equality sign, right? So there always has to be the equality symbol in it. So that can either be directly because we have the null hypothesis being that it is equal, or we can say it's greater than or equal to, or we can say it's less than or equal to, right? In every one of these cases, this equality symbol is going to be important, okay? So the null hypothesis needs to have that equality sign in it. In terms of notation, we're going to denote the null hypothesis using an H and then a subscript 0. We typically will refer to this as H naught or just the null hypothesis, right? So if you read this symbol, you can read it out as H naught or you can read it out as the null hypothesis. Both are perfectly acceptable. And so we might write for something like, the null hypothesis is that mu equals 5. And this is capturing the idea that the population mean is equal to 5, right? So this is an equality-based null hypothesis. We might say that the null hypothesis is that the population mean is less than or equal to 16. Again, this is going to be an acceptable null hypothesis, right? It has the equality sign there. We might say something like that the null hypothesis is that the parameter value is greater than or equal to 0.38. All of these are going to be valid null hypotheses because they are statements about some population parameter, right? So that's the first piece that we require. They're comparing it to some value as the second piece, and they all have the equality sign in them, right? Equal, less than or equal to, greater than or equal to, right? In each one of these situations, the equality sign is there, and so these are all valid null hypotheses. So if we have the null hypothesis being the default state of the world, then the alternative hypothesis is going to be set up in contrast to that, right? So the alternative is defined as what our alternative to the null hypothesis is going to be. Okay, so it's taken to be not the null hypothesis, right? If we say the mean is equal to 5, then the alternative is that it's not equal to 5. If we say that the mean is greater than or equal to 16, then the alternative is that it's less than 16, right? So the alternative is always being defined in contrast to the null. You take whatever the null hypothesis is, whatever that's not is the alternative, okay? So we can only define alternatives in the context of some specific null hypothesis, right? So they're always defined contrastively to the null. Typically, because they're defined in contrast to the null, that means that they're going to be specified either using a not equals, a less than, or a greater than sign here, right? So the alternative is specified as the opposite of the null. If the null has the equal sign, then the alternative is not going to have the equal sign. Okay. We're going to use the notation H sub A or H sub 1 in order to define the alternative, and we'll frequently just use either of these notations and we'll speak them as the alternative, right? So if we go back to the examples, right, we had the null hypothesis mu equals 5. That's going to correspond to having an alternative of mu not equals 5, right? We take whatever the null hypothesis is, which in this case, mu is equal to 5, and we say, well, what's not that? Mu is not equal to 5. Right? So we just sort of flip around the null hypothesis directly. We take the null hypothesis to be mu is less than or equal to 16. And so the opposite of that, well, mu is greater than 16. So that's going to become our alternative there. We take the null to be the proportion is greater than or equal to 0.38. That's going to correspond to the alternative. The proportion is less than 0.38. Right? And so again, the alternative is always set up in contrast. Now, another way that we can think about the alternative, and this is probably the most productive way to think about the alternative, is it's the statement that we require evidence to believe, right? So we're not going to just think that the alternative is true. We need evidence to know that the alternative is true. And so in most situations, the alternative is the thing that we actually want to show. So if you think about, say, a medical trial, right, what we want to show is that the treatment is going to have a positive effect. And so your alternative has to capture this idea of treatment having a positive effect, right? The null is then going to be the opposite of this, right? And in that case, the null is, well, the treatment has no effect, right? Which is also still the most conservative way that we can go about acting, right? We need evidence to know that the treatment actually does have a positive effect. We're not just going to assume that any random treatment is going to help, right? And so we can think about the alternative as being whatever we're actually trying to show. It's what do we need evidence for? What is it that we're actually hoping to conclude from this experiment? And so, in a sense, the alternative is really giving us the answer to the question of what are we asking of the data, right? What conclusion are we trying to draw? What do we actually want to know? Do we want to know, is this treatment actually effective? If so, that's what our alternative needs to be. it's useful to go through sort of as many examples as you can to start trying to identify what the null and alternatives are going to be in various scenarios. And so we can take a look at a few here. The first one is being drawn from medicine. So medical researchers are considering a new medication that's designed to reduce an individual's systolic blood pressure. They run an experiment testing whether this medication has an effect on blood pressure or not. Okay. And so we have to decide in this case, well, what is the null and what is the alternative? And in a couple of different ways we can go about thinking through this, right? So the first thing is they're trying to test whether this medication has an effect or not. Okay. And so if they want to conclude this medication has an effect, right, we need that to be the alternative hypothesis right here, right? So this medication has an effect has to become the alternative because that's what we're actually trying to show, right? Another way we could think about this is, well, what is our most conservative thing? What is the thing that we're going to assume without evidence? And the idea is that you're going to assume that the thing doesn't have any impact on your blood pressure unless you had evidence that it actually did, right? So the default assumption is going to be, well, this new treatment doesn't actually impact blood pressure, okay? And both of these are saying exactly the same thing. In this case, what we're thinking about here is if there's not going to be any effect, then what we're saying is that the effect is 0 is going to be our null hypothesis, right? So we'll take mu to be the effect of treatment, right? That's the population parameter here. And the idea is that if we take the null hypothesis to be that mu is equal to 0, there is no effect of treatment, then we can contrast that with the alternative that there is some effect of treatment, right? And so we can have mu equals 0 versus the alternative mu is not equal to 0, okay? We take a look at a business example here. So they're trying to discern whether a recent advertising campaign increased their quarterly revenue. So again, we can ask ourselves either, what are you going to believe without evidence, or what are you trying to show? And what they're trying to show is, did this recent advertising campaign increase their quarterly revenue? Whatever you're trying to show has to be your alternative, right? And so if we take, again, mu to be their change in quarterly revenue, what we're asking here is, did it increase it? Right? So is the quarterly revenue higher? Is it a positive value? Okay, and so that's going to have to be our alternative. The other piece that we could think about here is, what's the most conservative thing to think about? Well, the most conservative in this case is going to be assuming that there was either no impact of advertising or perhaps a negative impact of advertising on your revenue, right? And so those are going to be your most sort of conservative assumptions. Both of them lead to the same conclusion here. So if we take mu to represent the change in revenue experienced by the company, then the null hypothesis is going to be that there was either no or negative change, right? So mu is less than or equal to 0. The alternative is that there was some positive change, right? And again, that's what they're trying to show, that there was some increase in quarterly revenue here. Okay. A third example here, researchers are attempting to discern whether there's a difference in the annual wages between female-identified workers and male-identified workers in some particular occupation. Okay, and so in this case, again, we have to ask, what are you trying to show? And whatever they're trying to show is going to become the alternative hypothesis. So they're attempting to discern whether there is a difference in the annual wages between female and male-identified workers. First thing to note here, or the second thing to note, I guess, is that there are two parameters going on, right? So there's the annual wages for female-identified, annual wages for male-identified workers, right? So this is going to be a statement based on two different parameters, right? But ultimately, they want to show if there is a difference, right? When we're looking, is there going to be a difference or not? And so in this case, the alternative is going to be there is a difference, right? So the mean of male workers and the mean of female-identified workers are different. The null is then that they're going to be the same, right? So mu f be the mean for female-identified workers, mu m be the mean for male-identified workers. Null hypothesis, mu f equals mu m versus the alternative that they're not equal to one another. Okay. One last example here. So biology researchers are wanting to understand if the proportion of pea plants with green pods from a particular population is less than the predicted Mendelian ratio of 3/4, right? And so what we're thinking about here is that they're thinking about the proportion of pea plants with green pods, right? So that proportion is going to be the parameter that they're thinking about here. And they want to show, that it's less than our predicted ratio of 3/4, right? So less than the predictive ratio of 3/4. This right here has to be your alternative because that's the thing you're actually trying to show. The sort of conservative null is that it is equal to or greater than this because they're looking, well, is it less than? So we take P to be the proportion of pea plants with green pods in the population. And they're trying to look at the null of this proportion is greater than or equal to 3/4 or 0.75 versus the alternative that is less than 0.75, right? And so there's our null and alternative hypothesis here. In each one of these cases, you can think about the alternative as what is the conclusion we're trying to draw, and then null as what is the default thing that we want to be believing here. So statistical hypotheses, in summary, are statements regarding the value of any parameter, or perhaps multiple parameters. The null hypothesis captures our default belief about the state of the world, and the alternative captures what we want to show. And by identifying what is the null hypothesis and what is the alternative hypothesis, we're able to convert questions for our data into statistical statements, and then we can use those statistical statements to actually test the hypotheses, right? So identifying the hypotheses is an important first step because what we're going to do there is we're going to move from the language of whatever subject we're in into statistical questions. And once we're dealing with statistical questions, we can use the framework of hypothesis testing to actually answer those questions and draw conclusions from the data that we're able to observe.